Hi, my name is Emily Vingerhoeds, and I'm a fourth-year environmental engineering student studying at Carleton University. This past year, I've been working with Professor Paul Van Giel on the OCE-supported research project entitled Proof of Concept Bioreactor Process Optimization Toolbox. This project was started in May 2008 and completed in April 2009. It's a project that is important to the waste management sector. You might be thinking, what's the difference between a bioreactor landfill and a traditional landfill? Well, a bioreactor landfill is actually a system which supports the degradation of waste at a much faster rate than can typically be seen in a traditional landfill. An efficient bioreactor system actually promotes the stabilization of waste, the production of energy in the form of methane gas, and the effective use of void airspace within the landfill. To have an efficient process, it's important to optimize the parameters of the waste stabilization process, such as temperature, moisture content, pH, and oxygen levels. The proof of concept project is actually considered the first phase of the future large-scale project entitled Bioreactor Process Optimization Toolbox. The large-scale project is aimed at changing operating procedures such as lift thickness, lift compaction, and moisture addition to obtain optimal waste stabilization and methane gas production within the bioreactor landfill. The large-scale project involves using a sensor network and a GPS system in an active field bioreactor landfill. Our proposed site is a cell in Waste Management's Sainte-Sophie Bioreactor Landfill in Quebec. The proof of concept phase project involves testing the instruments which will be used in the sensor network in the large-scale project to make sure that they can withstand the vertical loading as well as the harsh chemical environment which is typically found in a bioreactor landfill. The instrument bundles which make up the sensor network are composed of 5 different instruments. The 5TE moisture sensor, which measures moisture content as well as electrical conductivity, the liquid settlement system, which measures the settlement of the waste in the landfill, the oxygen sensor, which measures the percentage of oxygen in the void air space in the waste, the total earth pressure cell, which measures the amount of loading placed on the instrument bundle within the waste, and the vibrating wire piezometer, which will be used to indicate any mounding of leachate within the vicinity of the instrument bundle. The instrument bundle was then tested in a lab-scale representation of a bioreactor landfill with the use of real waste. The first step for the installation was to distribute the waste evenly in the bin in about ½ meter lift. On top of this waste layer, I placed the instrument bundle, covered it with some sand for protection, and wrapped it in a geotextile blanket. The third step was to finish filling the bin up with waste. And the fourth step included covering the waste with a layer of geotextile as well as plastic sheeting. Our instrument bundle was tested in the lab-scale representation of a bioreactor landfill for 4 months. During the 4 months, we simulated a harsh chemical environment as well as extreme vertical loading. The harsh chemical environment was simulated through the addition of raw leachate directly to the waste. We also simulated loading to represent additional lifts of waste being placed on top of our instrument bundle. This project concluded that the instrument bundles will be able to withstand vertical loading as well as a harsh chemical environment, which is typical of a field bioreactor landfill. The knowledge gained from this experiment regarding the instrument bundles will be applied to the future large-scale project for the sensor network. The large-scale project is important as it will determine the optimal operating procedures to achieve an efficient bioreactor landfill system, such that we can obtain optimal amounts of waste stabilization, methane gas, as well as maximizing the void airspace in the landfill. Our main contributors for this project were Waste Management and Ontario Centres of Excellence. We also had input from 5 consultants, Jaeger Hems Limited, Golder Associates, WISA, Genevar, and AECOM, with some invaluable input from Alston Associates. Our instruments for this proof of concept phase project, as well as the future large-scale project, come from Hoskins Scientific, RST Instruments, and CSP Group.